Hello student, welcome to my channel Learn Physics. Today I will be discussing the numericals of motion of Ncert chapter 8. I have already uploaded the video of theory of motion, Newton laws of motion and forces, work, energy, power, gravitation and sound. These videos will be extremely helpful for you. I will give the link of this video in my description. You can watch this video. Now let's start. Look at this. Ncert numerical 2. A farmer completes one round in 40 seconds of a square garden of side 10 meter. Now we have to calculate the magnitude of displacement with respect to the initial point after 2 minutes 20 seconds. Now number of revolution in 2 minutes 20 seconds. So this is the 2 into 60 plus 20. This divided by 40. This is the number of revolution. Now look at this, 60 into 2, 120, 120 into 2, that is 140. So look at this is the 140 divided by 40, this is the 3.5. Okay, so farmer completes 3.5 revolution in 2 minutes 20 seconds. So the farmer reaches from this point to this point. So look at this is the displacement. Look at this is a right angle triangle. This is the 10 meter, this is the 10 meter. So displacement is the distance between initial point and final point. So displacement S is equal to AC, that is equal to root under of, look at this is the 10 square plus 10 square. So this is the 10 square plus 10 square. So this is the 10 root 2 meter. That is 10 into 1.414. That is 14.14 meter. Okay, understood? Next. Now look at this numerical 5. A signal from a spaceship takes 5 minutes to reach the earth with speed 3 into 10 to the power 8 meter per second. We have to calculate the distance of spaceship from the earth surface. Look at this, the formula is equal to distance equal to speed into time. Look at this, here speed is given and time is also given. Therefore, look at this, S equal to, this is the C into T. C is the 3 into 10 to the power 8 meter per second into, look at this is the 300 second. So this is the 9 into 10 to the power 10 meter is the distance of spaceship from the earth surface. Look at this, sum number 2. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. We have to calculate the acceleration. We know acceleration is the rate of change of velocity with respect to time. Look at this is the formula of acceleration. So look at this, here A equal to, this is the V minus U divided by T. Look at this is the 400 by 18. So look at this is the 400 by 18 minus, look at this 60 into 5. So this is the 300 by 18 whole divided by, this is the 5 second. Okay, now look at this, here LCM is 18 and this is the 400 minus 300 and this is the 5. So look at this is the 100 by 18 into 5. Look at this and this is the 20, this and this is the 10 and this is the 9. So acceleration A equal to 10 by 9. Therefore this is the 1.1 meter per second square. Okay, Understood? Next, look at this sum number 3. A train starts from a station with constant acceleration, gains the velocity of 40 km per hour in 10 minutes. We have to calculate acceleration. We know acceleration is the rate of change of velocity with respect to time. So acceleration A equal to change of velocity divided by time, that is v minus u by t. Look at this, here u given, v given and t also given. So we can easily calculate the acceleration. Therefore A equal to, this is the v minus u divided by t. Look at this, here v is the 100 by 9 minus 0 whole divided by, this is the 600. This is the meter per second square. So this is the 100 divided by 9 into 600, that is this and this cancel out. So this is the 1 by 54 meter per second square is the acceleration of the train. Okay. Now look at this, a bus starting from rest moves with constant acceleration of 0.1 meter per second square for 120 seconds. We have to calculate the final velocity v equal to u plus at and distance covered ut plus half a t square. So now look at this, here v equal to, this is the u plus a into t. Here u equal to 0, a equal to 0.1 into, this is the t, that is the 120. So look at this, this is the 12 meter per second is the final velocity of the bus. Next, distance covered. Look at this, distance covered s equals to ut plus half a, this is the t square. Now here u equal to 0, t is the 120 plus half, this is the 0.1 and this is the 120 whole square. Look at this, this is the 0 plus half into, this is the 0.1 and this is the 120 into 120. Look at this, this and this is the 60. So look at this, 0.1 into 120, so this is the 12 into 60. Now 12 into 60, so this is the 720 meter. Therefore distance covered is equal to 720 meter. Okay. Next, look at this, a train moves with 90 km per hour. Brakes are applied so as to it produces a retardation of 0.5 meter per second square. We have to calculate distance covered before coming to rest. Now look at this, here u given, v given, retardation given, we have to calculate s. So the required formula is v square equal to u square plus 2as. Look at this, here v square equal to u square plus 2as. Look at this, this is the 0 square, u is the 25 whole square plus 2 into minus 0.5 into s. So look at this, this is the, look at this, 2 into 0.5, that is 1. So this is the s equal to, this is the 25 whole square. So this is the 6 to 5. Therefore distance covered before coming to rest is the 625 meter. Okay, understood? Next, look at this, a trolley moves down on an inclined plane with an acceleration 2 centimeter per second square from rest. We have to calculate velocity after 3 seconds. We know the final velocity v equal to initial velocity plus acceleration into time. So we can calculate final velocity using this formula. Now look at this, here v equal to, this is the 0 plus a is the 2 and t is the 3. Therefore this is the 6 centimeter per second is the velocity of the trolley after 3 seconds on the inclined plane. Okay. Now look at this. A racing car starts with an acceleration 4 meter per second square from rest. We have to calculate distance covered in first 10 seconds. Now look at this. The formula of distance is s equals to ut plus half a t square. Therefore look at this. This is the s equal to ut plus half into a into t square. Look at this here. This is the 0 and this is the 10 plus half. A is the 4 and t is the 10 whole square. Look at this. This is the 0 plus look at this and this is the 2. So 2 into this is the 10 square means 100. So this is the 200. Therefore distance covered by the racing car in first 10 seconds, this is equal to 200 meter. Okay, understood? Look at this. A stone is projected vertically upward with velocity 5 meter per second. We have to calculate the time taken by the stone to reach the ground, that is t equal to 2 u by g, and maximum height ascent by the stone, this equal to u square by 2g. Look at this. If we put the value of u and g, we can calculate t and h. So t is the time of flight, this is the 2 into u is the 5 and g is the 10. So this is the 1 second. Okay. Now h equal to this is the u square by 2g. U is the 5 whole square, 2 into 10. So look at this. This is the 25 by 10. So this is the 1.25 meter. Okay. So height ascent by the stone is 1.25 meter and time taken by it to reach ground is 1 second. Okay. Now look at this. An athlete completes one round in a circular track of diameter 200 meter in 40 seconds. We have to calculate displacement and distance in 2 minutes 20 seconds. Now first of all, number of revolution in 2 minutes 20 seconds. So this is the 2 into 60 plus 20 whole divided by 40. So look at this. This is the 140 divided by 40. Now this and this cancel out. So this is the 7 by 2. So this is the 3.5. Therefore the athlete completes 3.5 revolution. Therefore if the athlete starts from here, so this is the 1 revolution, this is the second revolution, this is the third revolution and final half revolution. So the athlete move. So initial position of the athlete here and final position of the athlete this position. So displacement S is equal to diameter. Okay. Now diameter is equal to, this is the 200 meter, this is the displacement. Now what is the distance? Distance is the perimeter into number of revolution. So distance is the perimeter. Perimeter means 2 pi r into number of revolution, that is 3.5. Look at this. This is the 2, pi is the 3.14, r is the, look at this, this is the 100 meter and 3.5. So this is the 3.5. Okay. Now look at this. This is the 2 into 314 into 3.5. Look at this, 2 into 3.5. So this is the 7 into 314. Therefore this equal to, this is the 28 and this is the 9 and this is the 21. So distance covered by the athlete, this is the 2198 meter. Okay, understood? Look at this. Joseph jogs from A to B of distance 300 meter in 2 minutes 30 seconds and then back to C of 100 meter in 60 seconds. We have to calculate average velocity and average speed between A and B and between A and C. Look at this. In a straight path AB, the magnitude of velocity and speed are equal. So look at this. In AB, the magnitude of velocity or speed, this equal to total distance S divided by time taken. S is the 300 meter and time is the 150 second. So this is the 2 meter per second is the magnitude of velocity or speed between the path A and B. Now between the path AC. Look at this. Here speed becomes total distance. Look at this total distance. This is the 300 plus 100. So this is the 400. Okay. And total time taken. This is the 150 plus 60. So look at this. This is the 210. So this is the 400 divided by 210. So this is the 40 by 21 is the speed of the particle between A and C. This is almost 1.9 meter per second. Now velocity, look at this. The magnitude of velocity is the straight distance between A and C. Look at this. This is the 300. This is the 100. So this is the 300 minus 100. So this is the 200. Now 200 divided by total time taken, that is 210. So look at this. This is the 20 by 21 meter per second equal to 0.95 meter per second. Okay, understood? Next, look at this. While driving to school, the speed of Abdul is 20 km per hour. In return journey, the speed was 40 km per hour. What will be the average speed? Here, distance covered during going to school or returning from the school are same. So, average speed V bar, this is the 2 V1 V2 divided by V1 plus V2. Now, this is the V1, this is the V2. So, put this value. Therefore, this is the 2 into 20 into 40 divided by 20 plus 40. This is the 40 into 40 divided by 60. Look at this. This and this cancel out. 2. This is the 2 and this is the 3. So this is the 80 by 3. So this is the 26.67 kilometer per hour is the average speed. Look at this. A motorboat starts from rest, accelerates 3 meter per second square for 8 seconds. We have to calculate distance covered in 8 seconds. Now the formula of distance covered in 8 seconds, this is the S equal to ut plus half a t square. Therefore, look at this. S equal to, this is the 0 into 8 plus half into a is the 3 and t is the 8 square. So this is the 0 plus half into 3 into 8 into 8. Now this and this is the 4. So look at this. This is the 12 into 8. So this is the 96. So distance covered by the motorboat in 8 seconds, this is the 96 meter. Okay, understood? Next, now look at this. A ball is dropped from height 20 meter. We have to calculate the time taken by the ball to reach the ground. G equal to 10 meter per second square. We have to calculate the velocity of the ball before striking the ground. Now look at this. Here h given, g given, so we can easily calculate t. So this is the 20 equal to 0 plus this is the half, g is the 10 and this is the t square. Look at this. This and this cancel out. So look at this. Half t square, this equal to 2. Therefore t square equal to 4 equal to 2 square. Therefore t equal to 2. Therefore time taken by the ball to reach the ground equal to 2 seconds. Now what is the velocity? velocity equal to u plus gt. So here v equal to u is the 0, g is the 10 and t is the 2. So t is the 20 meter per second. Therefore velocity of the ball just before touching the ground, this is the 20 meter per second. Okay, look at this. A circular orbit revolves in a circular path of radius 42250 km in 24 hours. We have to calculate the orbital velocity. Look at this, the orbital velocity is the 2 pi r by t. So look at this here, this is the 2 into pi into 42250 divided by 24. Okay, now this and this cancel out, this is the 12. So this is the pi into 42250 divided by 12 kilometer per hour. Okay, this equal to 11,055 kilometer per hour is the orbital velocity of the satellite. Okay, many thanks for watching this video. This video will be extremely helpful for your class test as well as foundation of NEET, main and advanced. Please like, share and comment on this. If you are new, please subscribe my channel to learn physics easily.